Welcome to NC Tweener Talks, powered by NC Idea, a weekly podcast by builders for builders, where we explore the startup journey from the idea to the exit and all the lessons in between, with an exclusive focus on founders from North Carolina. Now, here's your host, serial founder and general partner of the NC Tweener Fund, Scot Wingo.
First, a huge thank you to our platinum sponsor. NC Idea Foundation fosters sustainable economic development with competitive grants and programs for entrepreneurs and funding to strengthen the North Carolina entrepreneurial ecosystem. First, a huge thank you to our gold sponsors. Today, we are featuring EisnerAmper. EisnerAmper helps tech companies from startups to public enterprises navigate growth with tailored accounting, tax, advisory, and outsourcing solutions. They have deep industry knowledge, support over 2,100 technology companies as well as investors. We'd also like to recognize our silver sponsors. Today, we are featuring Automated Consulting Group. Ready to transform your business with AI? Automated Consulting Group delivers executive workshops, fractional CAIO guidance, and custom AI solutions built for your business. Thank you again to all of our sponsors for supporting the North Carolina Tweener Talks and the entire Tweener community. It takes an ecosystem to build a thriving community, and sponsors like these are invaluable. Welcome to this episode of North Carolina Tweener Talks. I'm your host, Scot Wingo. We're excited to have you here. Before we go on, this is a great time to like, share, comment. It always helps us. And remember, you can always subscribe over at our Substack, which is called North Carolina Tweener Times. Today's guest is from Natrx. Here in North Carolina, we have this interesting set of companies that are way underknown. We're going to start a series here where we start talking more about these companies because we've got a cluster, if you will. And what these companies have in common is they require really amazing engineering. They're solving really interesting problems, and they have a physicality to them, but also a software component and a variety of other things. They also, because of the physicality, they choose North Carolina for our access to great engineering talent and business talent, but also because we're close to the mountains, the ocean, and relatively inexpensively have a farm here. If you need something like that, you can build a production facility. You can manufacture things here in North Carolina. So that results in some really interesting companies that are really not very well known, that we're going to start shining more of a light on here at North Carolina Tweener Talks. Many of these we have decided to invest in at the Tweener Fund. So that is how we know so much about them. We like these types of companies. It is part of the diversity of the state's different startup ecosystem. And also as an investment vehicle, we like diverse different investments. So on today's show, we have Tad Schwendler, and he is the COO of Natrx. And I won't tell you what they do or build. It does have to do with coastal waterways and how we protect our coast, not only in North Carolina, but in the overall United States. It is insanely fascinating what they are building. And there is a physical component to this. So Tad is going to show some things on the screen on our YouTube channel. If you're on audio, be sure to head over to Tweener Times, where we'll have screenshots of these so you can kind of see what's going on there. Thanks, and I hope you enjoy this as much as popular, and you enjoy this little series of the physical manufacturing companies that have chosen North Carolina to start their companies. Enjoy. Welcome to North Carolina Tweener Talks. I'm your host, Scot Wingo. Today, I'm joined by Tad Schwendler. He is the COO of one of our portfolio companies and a North Carolina startup called Natrx. Tad, welcome to the show.
Hi, Scott. Thanks for having me. It's great to talk to you.
Yeah, it turns out you and I have not had the pleasure of meeting, I don't think, but I saw that unless you come to our events, and at those I meet 70 people, and it's very hard for me to unpack who all I've met, but we're kind of Kevin Bacon, as often happens in the triangle. We've got like less than, not 7 degrees of separation, but we've got 1,001 degrees of separation. So good to have you on the show. Let's start with your background. Where have you worked before? And then launch into Natrx and your role there, and we'll update on the company and what you guys are doing.
Yeah, great. Well, I grew up in the Atlanta area, but I came up to the Triangle for business school. at Duke. So that was kind of what first brought me to the Triangle. And uh, post business school, I left for a couple of years, but I moved back in 2007, and so I have been here in the Triangle for longer in my adult life than really any place else. And most of my professional career has been around corporate development kinds of initiatives. So strategic finance, M&A, business development, a lot of transactional kinds of things. And I've done a mix of, large corporate. Much of my career was on the buy side, so leading corporate development programs for larger corporate entities. My last kind of corporate development role was with a company, Max Point, that was ultimately acquired. And after that, I kind of transitioned out. I wanted to focus on some more entrepreneurial things. And that was eventually what led me to meet the Natrx team.
Got it. Then, so what does a COO do in this context?
Yeah, well, so if we go back to when I met Natrx, they were extremely early at that point, and I was doing some consulting related to my corporate development background. And so a lot of that initial work was, what do we think the business model might start to look like? How do we put some numbers to that in financial models? How can we work with some, organizations that have expressed interest to get that a little bit more formalized? So some of these early kind of adopter and partnership kind of relationships. And then, how do we raise some capital to be able to go a little faster to do those kinds of things? So those were the kinds of things that I got involved with very early on. And after about a year and a half of working with the Natrx team on that kind of consulting or project-oriented basis, I think I was really excited by the opportunity, the progress that we had made, the technology that we were building. And so I joined as part of the leadership team full time. And so the role of COO is really just kind of formalizing some of the things I was already doing. So I lead our finance function, but I'm also very involved in strategy, business development, capital raising. We are a manufacturing organization. So we have a large manufacturing facility down in Louisiana. So I'm also very involved with the true operation side of manufacturing structures. There's some pretty significant logistics elements to what we do. So I help manage a lot of the logistics organizations. So really I touch, kind of all parts of the organization. But I am not, we have a lot of technical folks here. My background is more on the business and finance side and a little less on the technical side.
Got it. Just occurred to me, back in your Duke days, did you, right out of undergrad, did you go to Duke for an MBA, or was this like the exec program?
No, I went to the daytime program. I had about 5 years of work experience. What was actually really interesting, and this is part of why I got excited about the Natrx opportunity. So when I was looking at undergrad programs, I looked at Duke very seriously. They have a program where you spend 3 years here in Durham and then a couple of years down at the coast and get some kind of a master's of marine science oriented degree. And that was very appealing to me, but I ended up going to Tulane down in New Orleans and studying economics and having this kind of more traditional business career. But I've always been really fascinated by marine science and ecology and some of those things. And obviously living in a place like Louisiana, where these land loss challenges and the challenges at the land-water interface are so acute, was another sort of contributing factor. And that's very much the kind of stuff that Natrx works on, is how do we better solve these land-water interface challenges? And so the opportunity to bring some of my corporate development experience to bear on an organization that was trying to solve some of these very relevant challenges was a great opportunity. Part of what makes coming to work fun. Yep.
Yeah, you get to do the two things you're passionate about all married together. That's when work is like that, it becomes fun and you don't really mind working at all.
That's right.
Let's go back to the founding story of Natrx. It's kind of interesting. I'll let you tell the story, but Louisiana is part of it. So I guess start there.
Sure. Yeah. I mean, if we go all the way back to the very origin, it was two guys that met at LSU in the bioagricultural engineering program, and they got involved with oyster reef restoration in the Gulf, Oysters are pretty incredible creatures. They do a lot for water quality, and they help protect the coastlines. Obviously, they have, a lot of people like to eat them and so forth. They're pretty incredible little creatures. And so these guys got involved in oyster reef restoration, and then both went on to become practicing coastal engineers. And over time, they grew a little frustrated with some of the traditional engineering techniques and approaches, which are very much oriented to how do we stop nature? How do we keep it out? And so some of that thesis was around, well, there's ways we can use technologies. How do we harness the power of the natural system to accomplish some kind of an engineering objective as opposed to trying to fight that? And so that was kind of the genesis of it. One of those guys ultimately moved to the Triangle, kind of followed his professor to get his PhD at NC State. And then through that so that was Matt, and he met Leonard and Nick, who came much more from a software and a digital sort of experience. And so that was the genesis of Natrx, was bringing these sort of coastal engineering and software-driven capabilities together. So Natrx was founded in late 2018, and the first year or two were very focused on kind of technology development, and then around 2021 was when we started really commercializing some of the things that we'd been working on.
Got it. And I know Leo is an NC State guy. What's Nick's background?
Nick grew up out on the West Coast, so he has a mechanical engineering background, but then much of his professional career has actually been more around software engineering, but very relevant because obviously the mechanical engineering is very helpful on the manufacturing side. And we really pair that manufacturing with a set of software and digital tools. And so we're kind of at that intersection of digitally enabled manufacturing. And that's Nick's background. Yep.
And is it kind of separate where the Louisiana founders are there and the Raleigh founders are here kind of thing? Or did everyone move? Or you guys just swap around constantly?
Yeah. Right.
Seems like a lot of back and forth, I imagine.
We do travel. So most of our team is here in North Carolina. Most of our kind of headquarters function is here in North Carolina. We do have a few folks down in Louisiana. And then obviously we have our manufacturing crew. And that facility is about an hour and 15 minutes southwest of New Orleans. So a very interesting part of the world. It's very much a working coast down there. But the majority of the team is here in North Carolina.
Yeah. And okay, so that was the founding story, and then explain to folks how this works and what it is you actually like do. And there is a physicality to this, and I asked you to bring some props. We'll put pictures of this in the show notes, but I think maybe showing some visuals would help at this part of the story. So walk us through, what does this thing do?
Sure. Well, so going back to this kind of concept of trying to stop water, I think probably a lot of listeners at some point have seen a breakwater or a seawall or something that's intended to protect a coastline. The consistent theme is that most of the tools that human beings have used historically are impervious. They're intended to stop the flow of water. And what our manufacturing technique enables us to do is to create, this is obviously a very small scale version, but we can create things that have a lot of complexity, a lot of void space. And so what we want to do is we want to create things that slow down the flow of water, that dissipate the energy, whether that's from a wave or some kind of flowing body, and create an environment where the natural systems can work more effectively. So if you promote sedimentation, promote the accumulation of natural material, that's actually helping you accomplish your objective. Or if you're growing oyster reefs. So our manufacturing process is unique in its ability to create that complexity. You could not do that with a traditional mold or a form or even an extrusion head printer. And it works really well in these land-water interfaces because we can go from a set of digital instructions to a physical unit very easily, and we can tune that to the objectives of whatever this initiative is. So less material, better function, tends to be a faster, more cost-effective outcome.
Yeah. And did you guys, so that looks like a Rubik's Cube. I'm going to call it the Rubik's Cube. I know it's not
Yep.
what it is, but uh, the, is that kind of like the standard thing, or do you like custom design it for every purpose, or have you iterated from, you started at A and now you're on triple Z? Tell a little story about it. I don't want anything proprietary, but it seems
Yeah.
like the form and function is really important here. And a lot of times that's an iterative process.
Right. Yeah. Well, when we first started, you could kind of think about every project was custom basically, and that's kind of around the time when I was doing the consulting work. At that point, we had started very small scale, kind of pilot scale production. At that point, every project was unique and custom, but that doesn't scale very well. And so what we have done over time is we have developed kind of families or categories of shapes. So like this one that I first showed, we call this a lattice. It's really good for a variety of applications. We use that pretty regularly. This is a different type of shape. We call it a wave slope, has a little bit of a sloped face and a back face. And so we have developed these families of shapes. We have about 15 families of shapes, different sizes, different applications. And we know that we can produce those cost effectively. We know that they work well for certain requirements, and that allows us to scale up. And over time, we add to the family of shapes. So, like one of the things that we finished producing this year, this is for a large coral restoration project in Hawaii. And so this is actually an assembly of 5 different shapes. So you've got kind of 4 shapes that interlock on the base and another shape that sits up on the top, right? And so we now have a family of shapes around these kinds of superstructures. So we're kind of balancing the ability to do something that's repeatable and scalable, but also as needed, we can do some customization.
Yeah, and it looks like again, it's a small screen and everything, but it looks like it almost corally, like it's got like a little bit of an organic feel around the edges. Is that are you doing that to it's nature's the best engineer, or is that to so the fish and local there may be a tourist, a human thing, and maybe a an animal thing? Like what's the root cause of that?
All of the above. So when all that roughness, rugosity, complexity, all those things are really effective at slowing down or reducing the energy of water. It's all extra points of friction. So that roughness is really helpful from an engineering perspective. From more of an environmental or a habitat perspective, that's also what creates the opportunity for all the bottom of the food chain kinds of things to thrive. They need that roughness, the complexity, the hiding spaces. And so if you can create the conditions where the bottom of the food chain is healthy, that's good for the whole system. And ultimately, a healthy system is more resilient than just a single structure, basically. And then, the other thing is that we get a lot of interest, a lot of sales because of the aesthetics. So they look a lot more natural than a big pile of rocks or a traditional sort of precast unit, which tends to, precasters are really good at doing the same shape over and over and over, but it's not very visually appealing. And so we actually just finished producing for a large breakwater project in Texas. And one of the things, this is right along the town waterfront, and the town was really attracted to the fact that there was a more natural aesthetic than the other options that were available to them.
Yeah. So you showed us the little ones, and those were looked like 4 or 5 inches by 5 inches. How big are these things?
Mm-hmm. Yeah. So our individual unit, like if you think about a lattice, this is basically a 3-foot cube. So our current format, we can produce these 3-foot cubes. And then obviously if we assemble them, then you're talking about something that's more like a 6-foot footprint, 6 feet high.
Okay, so this is not deep. This is not in the in a trench or something. This is kind of getting relatively close to the coast. 6 feet depth. It may be down. Well, how deep is the water you're putting these things into?
Depends a little bit on the application. So if we're doing something like this as a breakwater, or these were basically the units we produced for Texas. That's right. You're somewhere in the tidal zone. So we talk about that as being intertidal. something like this big coral restoration project. So this will be about 3/4 of a mile offshore of Waikiki Beach in about 40 to 60 feet of water. So that would be like a deep water application.
Okay, cool. And wow, I've got 1,000 questions. Let's come back to the implementation or the delivery, I guess is what we'd call it. But uh, how? So I know that this is called dry forming, this process that you guys do, and you guys have basically, as an investor, I get the updates. I'm not going to reveal any super secret stuff, but um, it is not easy to make these things, right? And I've seen there's a lot of startups. There's a big one in Austin you may be familiar with. I'm sure it's like a business case study where they're trying to make houses out of concrete, and concrete's notoriously cement is notoriously hard to work with because it's got a mixture in a dry and a wetness and like way more complicated than the average person. I didn't take mechanical engineering, but the people that did cement, they had to take like 2 or 3 cement classes because it was very complicated and it always kicked their butt. It was like the organic chemistry of mechanical engineering. Is this thing cement? And then tell us a little bit like the complexity that comes along with the dry forming process.
Yep. Yeah, you are exactly right. So, starting with the traditional method, as you said, the traditional way of forming concrete is that you create a slurry. You have a binder, that's the cement, you have liquids, and you have aggregate. And you mix that up, you create that slurry. And anytime you're working with a slurry, there are very specific tolerances, there's a lot of challenges, a lot of science around it. And we have turned that process kind of on its head. So we start with a set of digital instructions, and those instructions go to a set of pumps. These are essentially like medical dosing pumps where we can control the amount and speed of injection of the liquid in a very specific way. And then we use those pumps to inject moisture into the dry mix. And wherever you pump some of that moisture in, you get a reaction. We call that a voxel. It's about a 1.5 to 2 inch little node. And as those nodes fuse together, that's what creates the units. And that's why we are able to create so much more complexity, roughness, void spaces, things that, like I said, you can't do it with a mold or a form or even an extrusion head printer because a printer is limited. You got to lay down levels of it. And so, yeah, we have a patent on this manufacturing process. This is something we have developed ourselves. It started out as a very kind of pilot sort of thing in a really small place in Raleigh, and we have continued to scale it up. And we now have a 10,000 square foot manufacturing facility in South Louisiana, and we are producing this Port Lavaca project was almost 1,300 units that we cranked out, and so over time, there's lots of opportunity to continue to scale, to continue to build automation, robotics. So we've been really pleased with the progress that we've made, and yet there's lots of opportunity to continue developing this process, and eventually we would like to make this manufacturing technology more broadly available.
Yeah. Okay, so you've got a factory, 10,000 square feet. That's pretty big. And what how big is the machine that makes these things? Is this like, so it's got to generate something 3 feet, so it's got to be substantially bigger than 3 feet. Is this a 10 by 10 conveyor belt kind of system, or what are we looking at? I imagine there has to be a drying. There's probably like a, people feeding it with raw materials on one side, and then it's doing its magic in the voxel thingy, and then it comes out and have to be dried, and then someone's going to have to take this thing and store it and do some post processing kind of thing to it, maybe some application hardening or something like that. Walk us through just like the big picture of how this works.
Right. Yeah. Well, so we start by mixing the material. So we use about 75% sand and about 25% Portland limestone cement. It's a mix that's been used in water and marine environments for a long time. We buy those in bulk. We have a mixer system that mixes them. We then fill up. We have basically their boxes. They're just containers that hold the dry mix. That box is moved into the print head, is really what we call it. And the print head is basically, a metal frame that has the injectors, the needles, and it's connected to the pump wall and the computer that has the digital instructions. I mean, the instructions are in the cloud. The computer sends them to the pumps, and so that system injects the moisture into the dry material. Depending on the size of the shape and some other parameters, the print time is generally between 15 minutes and an hour. And then that gets moved out of the print head. Typically, we cure that overnight, so you get some initial hardening. And then we have a step called breakdown. So it goes into a station where we basically vibrate off the unreacted material. That unreacted material goes back into the production process, and then the unit is there, and we take that. There's another step then, the hydration step. So we have a saturation system. We basically dunk that unit. As you get more moisture into it, it gets a lot stronger. And so after that saturation step, we let it cure for about a week, and then they're ready to go. And that's basically the process. Yeah.
How much is a 3x3 block weigh? Is this like 80 pounds? Seems like if it a solid block would probably be 80, maybe it's more like 45.
So something like this is a little bit under a ton, so just under 2,000 pounds.
Oh, holy cow! Okay, that's way heavier than I was guessing.
Yeah. So if we had a full box with no voids, it would be about 4,000 pounds, so about 2 tons. With that water weight adds a lot to it. So a unit pre-saturation weighs less than one that's post-saturation. And then something like these coral ones, like this, is about 12,000 pounds.
Wow.
So it's heavy and beefy. Yep. That's right.
Yeah, it seems like transportation cost is going to be high. So therefore, do you envision a world where these little factories are all up and down the various coasts? Because seems like getting it close to the coast is important. Louisiana, you're good, but then Texas, or like, I think you guys have done some stuff in North Carolina. So
yeah, quite a bit.
Yeah. Shipping these things is not fun. So you got to figure out how to do this.
Yeah. And I think, that's an area where, so our initial thesis was that we would have manufacturing nodes deployed much more quickly. I think as we got into it and we learned about the process, what we determined was that it made more sense to continue to invest in the main manufacturing facility before we tried to miniaturize and deploy more facilities. So we have been very focused on maturation at the existing facility.
Yeah, you don't want to replicate it too early because then you get 6 things that are hard to babysit. Yeah,
right. Exactly. It's still typically, we have the most installations in Louisiana, but Virginia, North Carolina, those are both really important markets for us. And typically we would ship those units on a flatbed truck. And setting aside the recent sort of, oil spikes, generally speaking, it's still very cost effective because again, we can accomplish the engineering objective with so much less material than a traditional approach. There's some room there. Like we drive project efficiency. Down in Louisiana, we're actually in the process where the factory is located. We're in a big industrial yard that's waterfront, deep water access. And so we often have customers come and pick the units up by barge, and we just load the stuff right onto a barge and off they go. And so you can actually barge these things straight over to Texas or to Florida. And we see that happening quite a bit as well. But yes, once the time is right, then we would certainly like to deploy, some additional manufacturing nodes. Florida is obviously a big market opportunity, the Chesapeake region. But then ultimately, I think what we'd like to do is we would like to make the manufacturing technology available so that other people are leveraging the technology and we're not necessarily building manufacturing nodes all over the world.
So with the voxel thing, is every one of these kind of like a little snowflake? Because it seems like at that point you're injecting some, randomness into the system.
Yes, that is true. Every unit has minor variations. Every one is very slightly different, and that is a natural outcome of the production process. And that's an interesting business challenge in certain ways. So nature and these land-water interfaces, they love variability and complexity. Human beings do not tend to love it quite as much. We like things that are more standard and replicable. And so figuring out how to balance those two is something that we work at every day.
Yeah. Yeah. How long do these last? So if you throw these out there, how long are they going to be there?
Mm-hmm. Well, our first exoform installations, that's what we call the units, are 2001. So we've got about 5 years of history with those. We had some predecessor technologies that kind of predated Natrx, and we've had installations of those 20 some odd years. There's no typically the reason that concrete breaks down in a marine environment is because there's rebar in it and the rebar spalls over time and it breaks apart. We don't use rebar in these structures typically. And in theory, if you get that natural system working where there's more sediment, there's natural growth over some period of time, you don't even know that there's a man-made structure there. And we do have units that are like that where you wouldn't even know that there's something there. It just looks like a natural reef.
Yeah. I'm a super novice on this. I'm a software guy, so this is probably the dumbest question you get asked. But coral is like basically it's a living, breathing thing. Can coral form and grow on these and like extend the structure and kind of like turn it into a cement coral hybrid or whatever there's probably a fancy word for that. Is that a thing?
Yeah, that's exactly right, and that's very much so. Like I said, this Hawaii coral restoration project, we've been working on a big one with a team of folks in Puerto Rico, coral restoration. But a lot of coral restoration science is around reproduction, fragmentation of the corals, and so forth. But you still need the right substrate, and you need the right features to where the whole system works well. And so this Hawaii project, portions of the team will actually plant corals. We built coral planting features into these units. And so they'll actually go out and they will plant corals on the units to kind of give it a head start. And then the natural, systems in the water over time, there will be natural settlement and more growth. And so that's absolutely the objective is that, 10, 20 years from now, you wouldn't even know that there's a man-made structure in this coral. It's just a coral reef.
Yeah. How do they get deployed? Do you have to put these on big boats that have cranes and things that kind of like plop them in the water? Like how does that work?
Yeah, it depends a little bit on the project, but a lot of times there's some kind of they're staged on some kind of a barge and you're using something like an excavator or a small crane or to place them very effectively. These coral units, obviously at 12,000 pounds, you need a little heavier duty equipment. But for a lot of the core sort of shoreline things we're doing, it's relatively lightweight. That's where a lot of our business advantage comes from. So, like we have a large project in Carrot Island, North Carolina. It's very close to Beaufort, North Carolina. And it's really shallow water. And so if you did that with rock, it's a lot of mobilization to get all the rock out there, you need heavy equipment and so forth. And by being able to do it with less material and a lighter weight solution, there's a lot of economic advantage to that. So anytime you're moving material, you're mobilizing equipment, you're staffing up labor, that tends to make the project much more expensive. And being able to accomplish the same objective with less material, less equipment, less labor, it's faster, it's more cost effective, and ultimately more of the work can get done.
Yeah. Who's the customer? Who pays for these things?
It varies a little bit. So in the Gulf, we kind of talk about having two primary channels. There are the actual asset owners, so that would be like energy companies, municipalities, ports. And then a lot of times we're working with the practitioners. So those are engineering services firms, environmental firms. There's some nonprofits and NGOs that do a lot of this kind of work. And in those cases, we're kind of enabling them with better tools. So, down in the Gulf region, we've had some early adopters in the energy industry. There's a lot of energy infrastructure in these coastal zones, and they need better tools to protect those assets. And so what we're doing them is giving them, there has not historically been a lot of innovation in this space. And so what we're doing is we're giving them more modern ways of protecting their infrastructure and being able to do it faster and more cost effectively, while also having a positive environmental impact. And so, yeah, a lot of times we are selling directly to those asset owners, but we also have a core, we have kind of core accounts in that specifier market that are designing us into engagements regularly. And that's been a real, that's been another thing for us from a business perspective and from a venture capital perspective. These are industries that tend to be very project oriented. And so we have we started out doing pilot projects, and then we were doing commercial projects to where we got to accounts, and now we're growing accounts. And then the next step is to get more of this into longer term contracted kinds of relationships. And that's been part of the Natrx journey.
Got it. So give us an idea of the scale. So we know you have a 10,000 square foot facility and it's pumping them out at, thousands at a pop. Give us an idea of the scale of the company. Usually with software, you'd look at like the number of people, but that's probably not a good analogy here. Maybe like deployments, whatever you're comfortable sharing, some idea of like how fast this is scaling.
Yeah. Well, we've done 85 plus physical deployments. So we have a pretty good track record. Those range anywhere from Maryland to Texas on the physical side. This Hawaii one hasn't actually gone in the water yet, but that'll be in Hawaii. We've done software related engagements even farther afield than that. Obviously, the software travels a little more easily than the physical units do. So we've deployed over 100,000 physical units. Our team is about 18 people plus our manufacturing crew, and generally the manufacturing crew is about 8 to 10 people. So all told, we're a little under 30 folks. We've been growing at about an 80% sort of CAGR revenue wise, and we will be, in the mid to upper single digits this year revenue wise.
Awesome. What's the future hold? So a lot of times you get into these things and you think, all right, we're going to use this for X. So I guess part of the embedded in this question is any interesting use cases that have come out of this that you didn't anticipate? And then B, what's like the future of Natrx? Where do y'all go from here?
Well, I think one of the things we're most excited about, so obviously we started and I think, your questions are consistent with that. Like a lot of our work early on was really in the coastal zone, pretty focused on these coastal applications. We're really excited. We've done half a dozen projects now that are much more, riverine. We see the opportunity as not just the coastal zone, but it's anywhere that you have that land water interface. And if you think about the overall kind of infrastructure of this country, data centers are a great example, right? All of these things, there's lots of complexity around developing all of this infrastructure, and all of the infrastructure, existing infrastructure, new infrastructure, they all have these water land challenges. And so we see the opportunity as the ability to bring better tools to really any kind of land water interface challenge. So we are getting ready to kind of launch a new, we plan to go out for a Series A round relatively soon to raise some capital to continue to scale it up. We've been super pleased. We are remarkably capital efficient for an organization that has CapEx needs. And we've been able to grow quickly and reinvest in the business. And like I said, get a lot of deployments out there, and we're really excited about what we're seeing. We hired our first senior sales leader earlier this year, and we're really pleased with the progress we're making on the sales front. So we're really excited about our opportunity to continue to commercialize this stuff.
Yeah. Any other new applications? Has someone ever come to you and said, "Hey, this would be good for building houses," or a non-coastal application or anything like that?
There are lots of possibilities and opportunities. I think the bigger challenge for us, Scott, is like really trying to stay focused on the core. Sometimes it's really easy to get excited about something that is new. And I think we have learned that lesson, that a lot of times those new things are harder to figure out than you want them to be. And so we have to remind ourselves to kind of stay focused. And that's, I think, a lot of what we're trying to do is stay focused on those core applications, keep getting better at them, keep building the base of users and adopters.
Cool. Well, there you heard it, folks. Right here in North Carolina, this is we actually have an unusually large number of companies like this, where you're looking for, you've got a physical component. You want engineering talent. You need a coast or a mountainal region or something like that. North Carolina is a state that brings all that in one place, and that's one of the really interesting things going on here. And you can. I know you have it in Louisiana, but you could easily build a 10,000 square foot facility here about the same cost as Louisiana. So what's nice is we have those more the regions that are a bit undeveloped, where they would welcome a facility like this, versus you could never do this project in San Francisco, right? That would be impossible. Even though there's water there, you cannot build a 10,000 square foot facility in California, period, probably.
Right.
So yeah. Thanks for coming on the show. Thanks for having us on the cap table. We always enjoy your updates. It's really cool to see. It is on my list of my bucket list to go see the manufacturing facility. I have even though I'm a software guy, I love nerding out on how all this stuff works and all the things you've learned. And someday I will get down there and see that.
Sounds great. Well, thanks for having me on. I mean, we love what we're doing. It's really exciting stuff, and absolutely agree. North Carolina is a great place to be building a company like this.
Yeah, and if you want to learn more, the company is spelled Natrx. Natrx.io is the website. Natrx.io. Tad is on LinkedIn and posts pretty frequently there, and then the company has a great LinkedIn page as well. Anywhere else that I don't think you guys have a corporate blog. We should. That's a feature request. Y'all should have a blog to talk about this, because I think there's probably a lot of people that would love learning more about this. So we'll put that out as a feature request.
Sounds good. All right.
Thanks, Tad.
Thanks, Scott.
NC Tweener Talks is hosted by Scot Wingo, presented and produced by NC Tweener Fund, which is powered by NC Idea, with creative assets and design support from our friends at Walk West. That's it for today's episode. A big thank you to our guests, sponsors, and the team that makes this podcast possible. If you enjoyed this episode, don't forget to subscribe, leave a review, and share it with someone who loves the startup stories coming out of North Carolina Tweener Talks and the entire Tweener community.